So today we will understand the working of window air conditioning system. Hello students, I hope you are doing well. So this topic is a point of interest because it is available. It is in our US syllabus, both in theory and as well as in your practical. So I find this topic to be very important. So that is why I come up with a presentation. This is very interesting and deep presentation. Now let me show you the contents of the presentation. Now we will study the AC heat load, main components of a window air conditioning system, how it works, then calculating the energy consumption, then definition of 1 ton of refrigeration, and then what are the various factors that can affect the efficiency of air conditioning system. Now let us start with the first we start with heat load. Now basically in domestic air conditioning system, as we all know, for domestic air conditioning system we have basically three systems. First is the most commonly used system is window air conditioning system. Second one is as we all know, it is you can say it is known as split air conditioning system, and third one is a centralized air conditioning system. Now window air conditioning system we will discuss in this presentation. We will focus only on window air conditioning system. Now split air conditioning system, there is a very, you can say, slight difference between window and split conditioning system, and the basic difference is that in case of split air conditioning system, the condenser, compressor and all the expansion devices, these will be separated from the main unit. Now why we separate out these units? Just to reduce the sound and vibration. That is usually the big problem in case of window air conditioning system. So just to take an advantage, we just separate out these units, which are most you can say noisable units. So let us start with the first slide, air conditioning heat load. Now what is the heat load? Basically, when if we want to install any air conditioning unit at any uh, space, or at any building, or at any, you can say, room, we are very much concerned about the heat load. Basically it is not a heat load, it is mostly known as cooling load. Now cooling load or heat load is a load which is which affect the air conditioning capacity. Now heat load is the amount of heat which is leaking inside the space. Now that much heat is required to be continuously removed out in order to keep its temperature constant. So before we mount any AC unit, install any AC unit in any space, we must know about the heat load. What is the total heat load? What is the total, you can say, cooling load of that space, so that we can come out with the exact amount of exact tonnage of refrigerating unit. Now where the heat coming from? Basically the heat is coming from, it may leak from the structure. Like we all know that there is in summers the solar radiation is very intense, so heat is usually comes into the structure by conduction. It may come through window panes by radiation also. It may also come into the your refrigerated space through convection also, through infiltrated air. That would be we see in the next line. So heat may leak into the through the roof, side walls and window panes. Second heat load is the most important heat load is the heat load of individual person. Now each and human body is usually uh, it is calculated as a single person is equivalent is can give a heat load up to 600 BTU per person. So we have to consider how much people it is going to accommodate in that space. So we must do our calculations with the maximum number of people that can be accommodated in that space. So we will multiply that factor with the 600 BTU per person. So next one is heat load of electrical appliances. Now every appliance emits a certain amount of heat. So these days we usually have lot of gadgets in our home, like fans, refrigerators, laptops, chargers, and LCD, LED TVs. computers, everything, even electric iron, you can say uh, microwave ovens. So all these gadgets, they also add heat load into the refrigerated space. So these equipment should also be taken into consideration while going for the calculation of heat load. So last one is the latent heat of air. Now what is infiltrated air? This is air which leaking inside the space through various openings, like through the sides of the windows, through sides of the doors or bottom of the doors, through cracks in the walls, through ventilators. So this air may be moist, and if moist air is coming inside the refrigerated space, then a lot of additional heat load is added into the refrigerated space. So these are the main factors. These are the main heat load factors which we should consider before calculating uh, any, you can say, heat load of a space. So next one is the way we since we are only focusing on the window air conditioning system. So next one is the window components of window air conditioning unit. So first one, the very important thing is the compressor. Now every window air conditioning system consists of a compressor unit. It may be rotary, it may be centrifugal, it may be reciprocating. So old units may contain reciprocating units, but nowadays mostly the compressors, they are coming with rotary compressors. They are more silent and more efficient. So second one is condenser unit. Condenser unit is the unit which is usually it is positioned outside your room. That is a rear backside of the your AC. Condenser unit used to condense the refrigerating vapors back into the liquid refrigerant. So most of the heat is, you can say, dissipate through the condenser unit. Condenser unit is basically most of the time it is made up of copper tubes. Next one is evaporator unit. The inside coil is known as evaporator unit. It is also known as chilled coil, cooling coil. So whatever air we the cool air come inside the room, it is coming through the evaporator coil. So this is also made up of copper, or in many cases made up of aluminum also, but copper is preferred. Next one is filter units. Now these days each and every AC is come with array of air filters. So these filter units may consist of mechanical filters as well as biomechanical filters. So these filter used to filter out the suspended particles or other impurities inside the air, as well as they may also condition the air conditioning system uh, chemical treatment also. On, you can say, they may condition chemically also air condition. So they may consist of activated charcoal or many other, you can say, latest technology. Next one is double shaft motor. Now basically window air conditioning is very efficient because it contain only single motor unit, and both the condenser you can say fan and the cooler blower is driven by a single shaft motor. So that is why it is more efficient than the split AC. So double shaft motor consists of blower on the front side and fan on the rear side. Rear side means fan on the condenser side. Next is the strainer. Strainer is a very small, you can say, integral part of any window air conditioning system. It is used to it arrests the you can say suspended moisture particles coming inside the which is this moisture particles in the vapors of the refrigerant. Now basically it is fitted inside the closed unit of this refrigerant cycle. Next is the refrigerant. Now there may be many different types of refrigerants, but nowadays R134A and the most latest one is R410A. It is most efficient refrigerant these days, and it is also very safe on environmental point of view. And the last one is the capillary tube. Capillary tube is a sort of expansion device. So it divide the unit into high pressure and low pressure side. So refrigerant liquid will expand when it pass through the long capillary tube, and then that low pressure liquid refrigerant is sent into the evaporator coil, into the cooling coil. So next we will now this is a cutaway section of your window air conditioning system. Now you can see here, let me show you some. Now you can say this is a wall, this is a wall, this is a, here again, this is the wall of the room. Uh, uh, mm, yeah, this is inside of our room, inside, and this is outside of. Now what we see here is, just I will take it. Yeah, so this is this one, this is evaporator coil, also known as cooling coil. Now on the front side, this is the inside of the room. On the rear side, it is the outside or external of the room temperature in this environment. Now what will happen, how AC works? Now the room air, which is initially at the room temperature, it enters into the, change into the slide there. Now room the air at the room temperature, it passes through the evaporator coil, that is cooling coil. In the process of passing over the cooling coil, the air and the ambient air get cools up, cool down. Then the blower, which is fitted at the rear of the this cooling coil, usually it sucks the air through this various you can say array of filters. Here the filter, many 2 or 3 layers of filters are fitted behind the grill, your main grill. So air will pass through these filters, then pass over through the cooling coil, then this air will again come out through the side grill. So this air which is coming out, it is a cooled air. So this air is supplied to the room at a, you can say, preset temperature and velocity. Now what will happen, that initially when we start the AC, initially the room and the air which is coming inside the AC, it will start cooling, and this start cooling down slowly. So this system and this cycle goes on until the air reaches at its set point. So it is not that the air which goes pass through the this cooling coil instantly come into the set point. It will take some time. It may take say 20 to 30 cycles before till it reaches to its thermostatic set temperature. So we have to wait for that time period. It does not matter how much temperature setting you set on your thermostat, because it will take a fixed amount of time before the air temperature reaches the temperature. So you have to wait for it. So it is better to set the temperature quite you can say close to 22 to 25 degrees Celsius. So it will give you maximum efficiency in this temperature range. So now what is happening at the rear side of the window AC? Now you can see here, this is a condenser coil. Now here the cooling cycle is this commencing. Now here this is a motor, here is a blower on the front side, there is a fan on the rear side. Now what will happen, the rear side of the condenser, it is very hot because the refrigerant vapors at high temperature and pressure, they are passing through this condenser. So what will how we cool down this condenser? We cool down this condenser with the help of ambient air, which is sucked through the both sides of the AC, from left side and right side. You can see here, sorry, from this and this both sides there is an opening on rear side of the AC from left and right side. So this fan, this sucks the air from the at ambient temperature and make them flow pass through the condenser coil. So in this process, the refrigerant vapor get cooled down, and then they again get this converted into the liquid refrigerant vapors. So in this way, this whole system works like a heat pump. How it works like a heat pump? Because it sucks air from the front side inside the room. It sucks it absorbs the heat from inside the room, and it throws out the heat to the environment. So it is taking heat from the room, throwing out the heat outside the room, taking heat from the room and throwing it outside the room. So in this way it is a sort of heat pump which pumps the heat from the room and pump out to the outside of the room. So these are the main units. So this is again I'm briefing on this main components. This is cooling coil, evaporator coil. This is blower. This is single motor. This is fan. This air at ambient temperature coming through this filters, then go into the this cooling coil. Then again, once it cool down, go this come out through this side grill. Now on the rear side, air is coming through both sides at ambient temperature, and it flow past the condenser coil. In this process, the refrigerant vapors cool down and again converted to the liquid this liquid phase. So here the latent heat of the refrigerant is rejected at the rear side, and on the front side the latent heat of refrigerant is absorbed. So this is why the refrigerant is the most important component of this whole system. So this whole unit is sealed from inside and outside. There should not be any leakage of any type from any, you can say, openings to make it the efficient system. So this is how it works. This is a cutaway section of HLAC. This is a blower. This is fan on the rear side. This is the chamber which shields the front and rear side. This is a compressor. This is condenser coil, and front side it is a evaporator coil. These are the arrays of filters. This is a front grill and all sort of things. These are controls. This is side grill. So let's move on to the next slide. Now I've already explained with all the things. AC draws in air through an array of front filters. Then filter air is passed through the cooling coil. This is known as evaporator coil. Then chilled air is thrown back inside the room by blower through the side grill. Then room temperature keeps lowering with each cycle of operation until the set temperature is achieved. Then the thermal comfort parameters are achieved by controlling airflow. Now basically the thermal you can say comfort zone, it all depends upon three parameters, that is what is the airflow, what is the air temperature, and what is the humidity of the air which is flowing inside the room. So we need to control all these parameters to stay in a you can say comfort region. The next is important terms used in air conditioning systems. Now 1 ton of refrigeration is it is very important term because we used to specify the capacity of any refrigerating unit in terms of tons of refrigeration, TR. You might have heard about this, then 1.5 ton of refrigerator, sorry, 1.1 ton of AC, 2 ton of AC, 3 tons of AC. What does it mean? Now what is the meaning of 1 ton? As per definition, the 1 ton of refrigeration means it is a cooling effect produced by melting of 1000 kg or 1 ton of ice homogeneously over a span of 24 hours. What does it mean in simple language? The 1 ton of refrigeration means that it is the amount of cooling effect produced if we melt 1 ton of ice in a enclosed space, and that amount of heat that ice will absorb in order to get melt down, the amount of heat it absorbs from the surroundings is equivalent to the amount of cooling effect produced. So this is the you can say units of this refrigeration, 1 ton of refrigeration. So capacity of ACs are usually measured as 1 ton of tons of refrigeration. Let's hold on. So next, let us move to the next slide. So 1 ton of refrigeration is we can also specify in terms of British thermal units, which is equivalent to 12,000 BTUs, and 1 ton of refrigeration is also equivalent to 3510 watts or 3.5 kilowatts. It means to produce 1 ton of refrigeration, on the thumb rule, it needs around 3.5 kilowatts of energy, electrical energy. 3.5 kilowatt of electrical energy means 3.5 units, electrical units. Now what are the various factors that affect the electricity consumption of an AC, or in other words, what are the factors which affect the efficiency of window air conditioning system. Now there are 4 or 5 factors, important factors, which can affect the efficiency of window AC. First is the star rating of window air conditioning system. Second is condition of air filters. Third is the temperature setting. Temperature setting means what is the setting, what temperature you have set on the thermostat while you are running the AC. Next is the thermal insulation of a room. What does it mean? We will discuss in the subsequent slides. And last one is the position of the condenser units. These are the 5 factors that can affect the efficiency of an AC. Now first we have shown that star rating. Now Bureau of Energy Efficiency, they usually as per their under their initiative of standards and labeling, they assign the star rating to various manufacturers, and various manufacturers have to undergo the various types of you can say testing for their air conditioning units before they get this star rating. So for example, here on the screen you can see AC with a 4-star rating. So 4-star rated AC is quite efficient. On electricity consumption point of view, it is quite efficient. So I always suggest you should go for at least 4-star rated air conditioning systems, because it will help you to save a lot of energy and savings from electricals and this consumption point of view. So here in this window you can see this is star rating on the top side. This is power saving guide. These are other parameters which are given by the Bureau of Energy Efficiency. This 2.90 is the EER, energy efficiency ratio. We will discuss this in another slide in my next presentation. Now star rating of an AC. The Bureau of Energy Efficiency is a single nodal agency which implement this policy for air conditioning systems, and this comes under the purview of Standards and Labeling Program, which initiated in the year 2006. So now these days AC and the AC comes into preview in 2012 only, I think, and under Standards and Labeling procedures. And at this moment, I think it is mandatory to earn at least 1-star label under minimum performance energy saving. So I think these days it is now gone up to 2-star label, a star at least in Indian market. It is the data of you can say 2000, I think 17. Now it has been modified again. So what next is the air filters. Importance of air filters. Now the efficiency of air conditioning system is mostly it is quite dependent on the quality of air filters, quality, or you can say condition of air filters. You can say that the clogged air filters put a strain on the fan, because if the air filters are not you can say they are not clean, or they are very you can say cloggy, in that case the air cannot pass through pass through them. In that case air cannot go into the condenser and this cooling coil. So in that case the efficiency of this air conditioning is severely affected, and moreover it also puts a lot of strain on the air conditioning system. So it is advisable to clean the air filters in once in a 15 days. Even I suggest you to clean air filter once in a week. In case of you can say while you are running AC, you must clean air filters once in a week. In this way you can save a lot of energy. So next is the poor air inflow can result in ice formation within the units. If for a long duration you do not clean the air filters, and the air will slowly stop flowing inside the unit, and in this way after some time there will be this ice formation in the unit. There may be ice formation on the you can say cooling coil, and your AC may ultimately go this may get failed at one point. So in various studies has shown that clog filter consumes 15% more energy. So this is the resources I've taken this figure from. These are actual figure based on the actual testing conditions. Now importance of set temperature. AC energy consumption increases with increasing temperature differential across the condenser and cooler. What does it mean? Now it means that whatever temperature we set when we are sitting inside the room, it is very important. Because if you set temperature very low, let us say if you set temperature around 18 degrees Celsius and the outside temperature is more than 42 degrees Celsius, so there is a lot of differential across the inside and outside temperature, or you can say there is a lot of differential across the condenser coil and cooler coil. So it will put a lot of strain on the AC, and moreover your energy consumption will increase drastically. On the contrary, if you set the temperature according to the ambient temperature, say that ambient temperature is keep on increasing, you also start increasing your internal temperature, room temperature. In this way, it will keep you good and well healthy conditions. Okay? And secondly, in this way, you can save a lot of energy. A set temperature of 26 degrees Celsius can be attained much earlier than set temperature of 20 degrees Celsius. As you can see, that if you set temperature at 26 degrees Celsius, it will reach much earlier. Before, otherwise, if you set it at 20 degrees Celsius, the compressor has to work very hard to reach at 20 degrees Celsius. The number of cycle may go double if it is at 20 degrees Celsius. In this way, the energy consumption is also increased. So compressor run for a longer duration, adding energy consumption we already discussed. So increase of each degree in a set temperature can save up to 5% of energy consumption. This is again I have taken this from a triple site. I forgot the name, full form of the site, but this is the actual figure. So you can save 5% energy by increasing the set temperature by 1 degree every 1 degree. So thermal insulation of a room. AC should be installed in a room which is centrally positioned in the house to ensure minimum solar radiation through the side walls. In the very first slide, I have shown you the heat load on a refrigerated and this air conditioning space. Now, if the room is located in centrally where there is no direct heat is coming from the solar radiation or thermal conduction, so in that room will be much better good option to install your AC, because that will give you a lot of efficiency, and the efficiency of the AC will be increased many times. So always install your AC where there is no direct thermal insulation coming inside the room. It is better if the room is covered through all the sides, and moreover the roof is also there well covered or shaded. Second is plug air leakages through windows and doors. So the infiltrated air which is coming inside the room from various openings, it should be plugged to ensure the better efficiency, because infiltrated air ultimately reduces the air conditioning efficiency. Avoid electrical appliances like refrigerators, electric irons, and a microwave oven. So you must avoid to this run these equipments while the AC is running, or you may separate these equipments out of the refrigerated space. Otherwise, it will put load on the air conditioning unit. Now, positioning of condenser unit. Now, condenser unit is the rear side of the AC, which is condenser unit. It you can say it dissipates the heat to the surroundings. So, condenser unit should be positioned in a well ventilated and shaded areas where there is no direct sunlight coming on its condenser coil. So it should be you should avoid direct solar radiation falling on the condenser unit. Provide a shade tree plantation or build a shed like this. You can see over here, this is a condenser coil, and this is a person has mounted a solar panel over it. It is giving you double benefit. It gives shade to the condenser unit. Moreover, it will also produce electricity. So thank you. This is how your room window is air conditioning works, and all these things which can help you to save a lot of energy. So I hope you all will keep in mind all these important these parameters and important tips to run your AC in summer air conditioning system. So thank you guys. See you soon, very soon. Thank you.